Alright, I want to take a look at the trig function here, graphs one more time. We saw these earlier, the sine and the cosine, where I'm following that red line. Unit circle. The angle is being plotted on the x-axis here. The length of that red side, which is the sine of that angle, because the hypotenuse is 1. So I'm drawing the graph of the sine as it goes around here. We saw this in a previous video. Okay. Likewise, the cosine. We also saw in a previous video. Cosine now is the x-coordinate there, with the hypotenuse being 1. So again, the angle is being plotted this way, and then the cosine of the angle is the vertical there. Next, I want to look at the tangent. Now, I'm going to animate this a little bit and then stop it right here. I want to point out here that this red side is the tangent of this angle. Now, again, it's the unit circle, but now rather than having the hypotenuse of length 1, I've got this adjacent side down here. The angle's right in there, and I've got this adjacent side going across. So, so the opposite over adjacent should be the tangent of the angle, and hence the length of this side is the tangent of this angle down here. So I'm plotting the angle along here, and then the length of that side vertically here. And you can watch as it goes around that it gets really big, and it comes in on the negative side, and then it gets really big again. Okay. As that's getting bigger and bigger and bigger, you're approaching the asymptote there. When you get to the other side of the asymptote, it looks kind of funny. It should be y over x here, right? With y positive and x negative. I'm choosing to just turn it around and do x positive and y negative, so that I can better see the graph, because it's kind of hard to draw it over there. So anyway, there's this is really the tangent that I'm looking at, y over x, but I'm plotting instead this y over x. They're equal to each other. When I get into the third quadrant here, with both x and y negative, I'm opting to take both x and y positive. Sorry, x and y, but y over x is my tangent instead of y over x there. But that shows me the graph of the tangent curve. You can see the intercepts at 0, and at pi, and at 2 pi. You can see the vertical asymptotes at pi over 2 here, and at 3 pi over 2 out there. Okay. Scrolling down to, did I not do the cotangent? Huh. I did the secant next here. I guess I know why I did the secant next. I'm looking at the secant here. Again, with the adjacent side being length 1, the hypotenuse will have length of secant, right? Because secant, hypotenuse divided by adjacent, is the secant of that angle. If the adjacent side is 1, then the length of this side has to be the secant of the angle. So, so here we go. As I set it in motion here, let's start off. Okay, so there's my first quadrant angle with the secant. And it gets bigger and bigger and bigger as you get close to pi over 2. At that asymptote at pi over 2, in the second quadrant, the secant, remember, is the hypotenuse divided by, so r over x. X is negative here. I'm plotting it back here, actually thinking of this is negative, I guess. But we're negative, still negative. X is still negative there. And now it's positive again. Negative through the second and third quadrants, positive through the fourth and first quadrants. Okay. Notice it's equal to 1 right here and right there when the cosine would be, and it's got a vertical asymptote at pi over 2 and at 3 pi over 2 where the cosine is equal to 0. All right. Cotangent. Okay, this time I've got this a little differently. I'm thinking about this angle right here, but by extending this out and drawing a tangent line to the top, what I end up doing is that top segment there is parallel to the bottom here, so the angle right down in there is the same as the angle up here. And what I've done now is I've made the opposite side, if you look at the triangle up above, the opposite side has length 1, opposite from this angle. So the cotangent of this angle would be this divided by 1. Hence the red side there has length cotangent of that angle. But that angle is the same as this angle, so the red is the cotangent of this angle down here. Right? Plotting with the angle along the x-axis and the length of the red side along the y-axis, I'm getting the cotangent. Here we go. Let me start right here. In the first quadrant, you see the cotangent is positive. It would be x over y. In the second quadrant, x over y becomes negative. In the third quadrant, x over y is now positive, so I'm thinking x over y up here. And negative again here because the x-coordinate is negative, but the y-coordinate, sorry, x-coordinate is positive, but y is negative. And there we go. So there's the cotangent. It's got asymptotes at 0 and at pi, and at 2 pi, that would be where the sine is equal to 0. And it's got intercepts there at pi over 2, and at 3 pi over 2, when the cosine is equal to 0. And lastly, we got the cosecant. Let's see, where's my triangle? Just a minute here, let me get it. There we go. So again, I'm using this angle, but I'm thinking of it up there. So the opposite side has length 1. Hypotenuse divided by opposite would be the cosecant. So this has got to be the cosecant because you're dividing by 1. So this should be hypotenuse divided by y, right? Positive here, positive in the second quadrant, right? The y-coordinate is still positive. Asymptote, though, I just missed the asymptote at pi. Let's get back here. There's an asymptote here at pi. And then I'm down here in the third quadrant where the y-coordinate is negative. And so I'm plotting back up here, thinking of the hypotenuse is negative now, which is a little different from what we've done before, but still. There's the graph of the cosecant. All right, all of them are kind of closely related to that unit circle one way or another. You draw the appropriate triangle with the right side highlighted, and you can see what it's doing as the angle keeps getting bigger and bigger and bigger. Okay, there you go.